Assalamu alaikum dear student. Bismillahirrahmanirrahim. Today our topic is reactions of group 2 element with oxygen and nitrogen. Reaction of group 2 element with oxygen. Preparation. Formation of simple oxides or preparation of simple oxides. The alkaline earth metals form the normal oxides of MO type, which are obtained by heating the metal in oxygen or by heating their carbonates at high temperature. For example, the reactions are given below. Calcium is heated with oxygen and calcium normal oxide is formed, and calcium carbonate is on heating. Calcium oxide and carbon dioxide are formed. Properties. These oxides are extremely stable white crystalline solids due to their high crystal lattice energy obtained by packing doubly charged ion in a sodium chloride type of lattice. Beryllium oxide and magnesium oxide are quite insoluble in water, while calcium oxide, strontium oxide, barium oxide react with water to give soluble hydroxide. Metal hydroxide, which are strong bases. Beryllium oxide is not always in nature. In fact, it is amphoteric since it reacts with acid to form salts and with alkalis to give beryllites. Here is the chemical reaction given showing a reaction of beryllium hydroxide with acid and base, and as a result beryllium chloride plus sodium berylates are obtained with water. The oxides of other metals are basic in character. Their basic character increase on moving down the group. Due to small size beryllium ion, beryllium oxide is covalent while other oxides are ionic. Although beryllium oxide is covalent, yet it has a higher melting point and is harder than the oxides of other metals as it is polymeric. Each beryllium atom is tetrahedrally coordinated by 4 oxygen atoms. Preparations of peroxides of group 2 element. The peroxides of heavier metals like calcium, strontium, barium can be obtained on heating the normal oxides with oxygen at high temperature. Here is the reaction given. Law of reaction is of barium oxide and oxygen and barium peroxide is obtained. Properties. The peroxides are white ionic solid having peroxide anion. They react with acid to produce hydrogen peroxide. Formation of nitrides on heating in air. All the elements burn in nitrogen to form nitrides M3N2 type. For example, calcium react with nitrogen and calcium nitride is obtained. These react with water to liberate ammonia, e.g. beryllium nitride is volatile while other nitrides are not so. Terms in solubility of the hydroxides, sulfates and carbonates. Solubility of the hydroxide. The hydroxide become more soluble as you go down the group. This is a trend which holds for the whole group and applies whichever set of data you choose. Some example may help you to remember the trend. Magnesium hydroxide appear to be insoluble in water. However, if you shake it with water, filter it and test the pH of the solution, you find that it is slightly alkaline. This shows that there are more hydroxide ions in the solution than there were in the original water. Some magnesium hydroxide must have dissolved calcium hydroxide solution is used as lime water. 1 liter of pure water will dissolve about 1 gram of calcium hydroxide at room temperature. Barium hydroxide is soluble enough to be able to produce a solution with a concentration of around 0.1 mole per dm cube at room temperature. Solubility of the sulfates. The sulfates become less soluble as you go down the group. Solubility of the carbonates. The carbonates tend to become less soluble as you go down the group. Carbonates are insoluble in water and therefore occur as solid rock mineral in nature. However, they dissolve in water containing CO2 due to the formation of bicarbonates. Here, the reaction of calcium carbonate, CO2, and water and produce calcium bicarbonates. Trends in thermal stability of the carbonates and nitrates. Effect of heat on group 2 carbonates. All carbonates decompose on heating at appropriate temperature, evolving CO2. The stability of the carbonates of these metals increase on moving down the group. This is illustrated by the values of the decomposition temperature of these carbonates as given below. Uh, Beryllium carbonates temperature, decomposition temperature is 25 degrees centigrade, while at the down group barium carbonate, its temperature is scale 1360 degrees centigrade. Effect of heat on group 2 nitrates. All the nitrates in the group undergo thermal decomposition to give the metal oxide, nitrogen dioxide, and oxygen. The nitrates are white solid and the oxides produced are also white solids. Bond nitrogen dioxide gas is given off together with oxygen. Magnesium and calcium nitrates normally have water of crystallization, and the solid may dissolve in its own water of crystallization to make a colorless solution before it starts to decompose. Again, if X represents any of these metals, then the chemical reaction can be given as group 2 element nitrates decompose into normal metal oxides, nitrogen dioxide, and oxygen. Both carbonates and nitrates become more thermally stable as you go down. The ones lower down have to be heated more strongly than those at the top before they will decompose. Here are questions. How beryllium differ from other members of its group? Beryllium, the first element of the group, differs from rest of alkaline earth metal due to its small atomic size and comparatively high electronegativity. The main point of differences are: first, hardness. Beryllium is the hardest of all the elements of its group. Second point is melting and boiling point. The melting and boiling point of beryllium are the highest. Third point is formation of covalent compounds. Beryllium has a tendency to form covalent compounds. When it reacts with other elements, the electronegativity difference is not so large and the bond is therefore covalent. Reaction with water. Beryllium does not react with water even at high temperature. Other alkaline metals decompose water, regulating it to gas. Reaction with hydrogen. Beryllium does not react with hydrogen directly to form its hydrides. Its hydride, however, has been prepared indirectly. The rest of the alkaline earth metal combine with hydrogen to form hydrides. The hydrides of beryllium and magnesium are covalent, whereas the hydrides of other metals are ionic. Reaction with alkalis. Beryllium reacts with alkalis to form hydrogen. Here the reaction is given: beryllium reacts with base, and here it's give over the hydrogen gas. Other alkaline earth metals do not react with alkalis. Behaviors of oxides and hydroxides. The oxides and hydroxides of beryllium are amphoteric, i.e. dissolve in both acids and alkalis to form salt. Behavior of carbides. Beryllium carbide is decomposed by water to form methane. The carbide of other alkaline earth metals are decomposed by water to form acetylene. Behavior of nitrides. Beryllium nitride is volatile, while the nitrides of other alkaline earth metals are non-volatile. Number of molecules of water of crystallization. The salt of beryllium ion cannot have more than 4 molecules of water of crystallization, while other alkaline metals have more than 4 molecules of water of crystallization. This is explained as follows. In case of beryllium ion, there are only 4 orbitals. Namely, one orbital can accept lone pair of electrons denoted by oxygen atom on each of the water molecule as shown below. On the other hand, other earth metal like magnesium can extend their coordination number to 6 by using one 3s, 3 3p and 2 3d orbitals belonging to their outer. In this diagram, the valence electronic configurations of beryllium atom is given below. Here you can see that this is the first one is the valence electronic configuration of beryllium atom. Second one is valence electronic configuration of beryllium ion. Here there are four vacant orbitals to which four molecules by donating its to lone pair can attach to these four vacant orbitals. Formation of complex compounds. Beryllium ion on account of its small size forms stable complex compounds like BF3, BF2, while uh, M2 plus ion derived from other alkaline earth metal form very few complex compounds and lost their quiz after completing uh, this lectures. Students should be these questions.